Harmonic motion. Harmonic motion is basically just a wave, like a sound wave, a ripple over the lake. Drop the pedal in, it has a ripple. Pull on a spring, it vibrates back and forth until it stops. There's two differences in harmonic motion that we're talking about today. Mostly we're going to be talking about simple harmonic motion. Simple harmonic motion is the fact that the wave doesn't dissipate, it just keeps going. The amplitude stays the same, it doesn't change. But dampened harmonic motion is very typical in what we usually experience, is that the wave gets smaller and smaller and smaller. Okay, so the amplitude changes over time. Alright, having said that, amplitude, can anybody tell me what, in their own words, what amplitude really is? Amplitude.
It's maximums and minimums?
It's how we get to the maximums and minimums. Yeah. Yeah.
I'd say like it's the amount away from zero.
The height and depth from a given point. And a given point is really where it's beginning. What he was saying is from zero, because typically that's where we're taking the sine function from. So the sine function, if we just talk about the sine function here, typical sine function, at time t being 0, the displacement is 0, meaning we're starting at 0. There's no displacement. This is where we're beginning. And we go up to the first part and then back down to its depth and then back to the beginning. And what is this called from this point to this point?
Period.
The period, yeah. Alright, keep that in mind. Alright, so here the amplitude is 1. Up 1 and also down 1 from our beginning value. Let's say that we drop a rock, a real big rock, in the middle of the lake, and it has a wave that is, pretty high, about 1 foot high. And it's going to be simple harmonic motion. That wave is going to go all the way across the lake. It's not going to dissipate. I want to know the distance from the top of the wave to the bottom of the lake if the lake is 10 feet deep. What would that distance be? Who said that? 11 feet. Alright, so you don't have to, you can redraw this if you want. So if I'm looking at that on an actual graph, this is the bottom of the lake. Here is 10 feet, and there's 11 and 9 feet, and I see the wave like that. Amplitude is 1. It started at 10. How would I write this to begin with in the equation? What does the 10 do? Where does that go in the equation? Do you remember? Where's the graph? Is the graph at 0?
It starts at 10.
It shifted up by that much. Do you remember where that number goes? Remember how we shift it up and down? Where's it go? We did all that graphing. You guys forgot where that goes? Where's the amplitude number go? Amplitude's 1. Where does that go?
Right before sine.
Right before the sine? Alright, so let's just start figuring this out. So the amplitude's 1, goes right in front of the sine, so we'll just leave it as 1 times the sine or just sine. And you guys said something about the period. We're going to call that W. The value. The period is not W, right? We called it K before. We got another formula we're going to talk about today that has K in it, so we're going to change this to W. So this W is the same as K. Alright? And the amplitude goes there, and any shifting up or down, we'll put K right here. K plus A sine WT. Alright. Having said that, we have 10 plus 1 sine of WT. We'll talk about the period here in a minute. What we're doing at the beginning of this section is just taking the information that they've given us and then making the equation. That's all. Cosine looks something like this. Starts at 1, goes to -1. So that's what it looks like, but it starts here. It has a displacement of whatever the amplitude is. It doesn't start at 0. So an example of that, this would be an example of a wave on a pond. It's starting at a normal point. There's no displacement, even though it's moved, the whole thing is shifted up by 10. There's no displacement until we drop the rock in the lake. Okay? Here, this would be like a spring, a coil. And let's say we pull the string up to this position. Alright? That would be a displacement of whatever it is that's moving it, like 2 feet. If we moved it 2 feet, then this whole thing would move up by 2, okay, and oscillate back and forth. So the amplitude there would be 2, back and forth, blah, 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 blah. But we'll do some examples to show that, okay? So when they say the displacement is 0, you're thinking about a sine function. If they say the displacement is something different than 0, then you're talking about the cosine. We're only dealing with the sine and cosine for these waves today. But you got to be able to decide when you're reading your story problems if you're dealing with sine or cosine. Alright? Okay, so we talked about amplitude. What do we know about period? What do we know about the period? Yeah, sine and cosine.
0 to 2 pi.
Huh?
Is it from 0 to 2 pi?
0 to 2 pi. So to find out what W is, 2 pi over W equals whatever the period is. Okay? We have a new thing called frequency. Frequency is over time. Over time, how many of those cycles do you have? A cycle is a period, okay? How many do you have over a certain period of time? And how we do that is the frequency is W over 2 pi. It is the reciprocal of the period. Okay, great. Now, let's do some problems. And the biggest part about what you're going to have to do here is finding what W is. Alright. I'm not going to graph because by now everybody in here ought to be experts at it. Given some information, here's example 12. Given the amplitude to be 24 feet and the period is 2 minutes, what is your equation? Y equals A sine of WT. We need A and we need W. First of all, what is A right off the bat?
Amplitude. Amplitude.
Amplitude, which is 24. So Y equals 24 sine of something times T. How do I find W? Period is 2 pi over W equal to, what is the period? 2. Everybody solve. That is pre-algebra and algebra right there. Solve for W, please. Cross multiply for 1. Everybody in here should be able to tell me what that is. See? Yeah. I was wondering what that was. Pretty good. Good job. What is it? It's close. Is that 4 pi? 104. But that's 2 over 1.
What'd you get?
Alright, look. I want W by itself, but it's in the denominator, so I multiply by W to move it. 2 pi equals 2W. This is a pre-calculus course. Divide off the 2. W is pi. And there is your answer. This is what you're going to have to do a lot. Alright, either given the period, use this function, this expression, or the frequency, use that expression. Alright, let's do another one. Example 14. The amplitude is 1.2 meters. The frequency is 0.5 hertz. I don't care about the units at the moment. Right has a displacement of 0 at this point. So you're going to use sine. Looks like we need to do a couple more of these. So tell me what you get for W, and then write the equation. Yes. Frequency is W over 2 pi. And you can use 0.5 or you can use 1/2. I don't care. So if I multiply both sides by 2 pi, W equals pi again. Y equals 1.2 sine of pi t. You got that right. Good. Alright, need to do another one. Alright, so here, so we're going to assume the displacement is at its maximum to start with. So which one are we going to use? Sine or cosine?
I'm sorry.
At time t being 0, the displacement is at its maximum. So is that sine or is that cosine? Cosine. Cosine begins at a maximum value. Alright, so let's do example 16. The amplitude is 35. The period is 8 seconds. So this is the exact same setup. Y equals A times the cosine of WT. Alright. You know A, now find W.
Is that 8S or 85?
8S. 8 seconds. Takes 8 seconds to complete this cycle of cosine. Raise your hand when you got it.
Do you have to make that like 0.08 or 0.8 or anything like that? No. Does it matter if it's second or minutes or anything?
No, there's no conversions yet. Chapter 6, we will get into some of that. Yes?
I got y equals 35 and cosine 16 pi. Is that right?
Well, okay, let's check it. So the period is 2 pi over W. The period is 8. Multiply by W. 2 pi.
So it's minus 1.
Divide off the 8. 5 over 4 equals W. So this would be pi over 4 times T. Do we need to do another one? Okay. Alright, I gotta look at this one. 6.25. Amplitude is number 18 is 6.25, and the frequency frequency is 60 hertz. Okay. Again, this is a maximum displacement at 0. So cosine. So use the frequency formula. Raise your hand if you got it. Very, very simple. This one should be. I don't know. That's right. Yes. Raise your hand if you have it. Good? Got 5 people?
Yep.
What's the ratio for frequency? W over 2 pi, and that equals 60, multiplied by 2 pi, W equals 120 pi. And that would be your answer, 6.25 cosine 120 pi t. Alright, you're going to have to do this again in the next thing I want you to do, so damped harmonic motion. Okay, so given this equation, y equals k times e to the negative ct sine of wt. It's the same thing for cosine, just switch it out from the sine. K is the initial amplitude, and C is your damping constant. I don't need a poster for this. If I have to use it, I'll put it in there for you. You have a lot of formulas, so a lot of things you gotta remember. W, obviously you're going to find it the same way. All you are doing at this point is just filling in the information given until we get to story problem. And that's really all you're doing in a story problem. But in a story problem, you got to use some common sense. And that's, it's kind of difficult sometimes. So if we take a look, let me see which one we want to look at. If I look at number 20, here we're going to use the cosine form. Number 20, K is 15. K is 15. C is 0.25, and the frequency is 0.6. All we have to do is plug in information. Y equals K is 15 times e to the negative c, negative 0.25 t, cosine. How do I find W? Are we given frequency or period? Frequency. Frequency is W over 2 pi equal to 0.6 multiplied by 2 pi. What do I get? 1.2 pi t. Was that difficult? Again, this is the part that's at the beginning, first 20 problems that you have to figure out. You're just filling in the information. You got it from here so far? Alright. I'm not going to show you another one of those, that's just using a different formula and plugging in information. What I do want to do is go over a couple story problems. Give you an example of what you need to do. Alright, let's talk about predator population models. So, predators and the population. So the more predators there are, what happens with your population?
Goes down.
Goes down. And then once it goes down, what happens to the predators?
It goes down.
They go down and the population then starts to go up. Okay, so are we starting, just your own thought process here, are we starting with a maximum population, do you think, or are we starting at a normal, I don't want to say normal, that insinuates that that's the answer. A middle of the road population, what do you think? When do predators come out?
At night.
No. Yeah, you may come out at night. For animals,
There are more.
huh?
There are more.
As far as population is concerned, that's what we're talking about.
Higher population.
When there's a higher population, we start to see more predators come out and it's visible. So here it's an understanding that we're starting with a maximum displacement. So what are we going to use, sine or cosine?
Cosine.
Cosine. Okay, so that's what makes these problems kind of difficult, because we have to really think about, gosh, what are we going to use? Is it the sine or is it the cosine? And, you know, you miss the whole problem if you use the wrong one. So we're going to use the cosine on this one. Let me read this to you. This is number 30 in your book. In a predator-prey model, the predator population is modeled by the function y equals 900 plus the cosine 2t plus 8,000. Why does that look strange? What? Or doesn't it look strange? I mean, does it look normal?
There's a plus in front of the 8,000.
Would it look normal if I did this?
Yeah.
Yeah, it would, but that's not what it is. So what's not normal about it?
There's a plus in front of the 8,000.
Yeah, we have a plus 8,000 there. That's the same thing as if I wrote it like this. Now does that look a little better? Just because the numbers are large doesn't mean anything. So what's that 8,000 mean? Population. And what do you think the maximum population is, just by looking at this?
8,000.
What is your amplitude? What's amplitude?
8,900.
900 is the amplitude. So, what do you think your maximum population is going to be? Somebody said it already. What? What?
He said 8,900.
8,900 is right. I thought you said 9,900. 8,900. Remember, this is how much this is moving up or down. In this case, it's moving up, right? So this piece right here would look like this. This would be 900, and this would be negative 900. Okay, and it would go like that. Except this gets moved up by 8,000. So this is 8,900. All right, so that changes the way this graph looks. I'm just trying to get you to use what you've been taught. Okay, on this graph, we're not starting at 0. We're cutting this off here. 8,000 is the midpoint, and you said 900 is your amplitude. So we go up to 8,900 and down to what? 7,000 what? 100. So the amplitude, or the graph, oscillates between 8,900 and 7,100. So the population goes from 8,900 to 7,100, depending on the predators. Okay, it's maximized at 8,900 and minimized at 7,100. That's what this would look like. Now we've not shifted this left and right yet, but there is no shifting left and right in this problem. All right, so just looking at the equation, you told me a whole lot. You told me what the maximum population was. You understand what the amplitude is. What's it asking for? Part A is asking for the maximum population. We answered. Part B is find the length of time between successive periods of maximum population. What does that mean? Where are the maximum populations on the graph? Well, there's one right here. Isn't it? At the top of each of these as time progresses. Here's maximum, 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 maximum. Well, it wants to know what this is. What do we call that? The period. The time between maximum populations. Just the period. How do I find the period?
2 pi.
Everybody find the period. What's W? If W is 2, you ought to be able to tell me what the period is.
Big old piece of pie.
How do I find period? Period.
What did you say W is?
Will you tell me what is W? What's up there? Where's, yeah, the W is 2.
Okay.
Period is 2 pi over W. If W is 2, what's 2 pi over 2? Pi. So the period is pi. You've not answered the question. Pi is not exactly what we're looking for. It's asking, find the length of time between the maximum populations. This is time here. How much time is pi in years? 3.14 years. So to go from one maximum value to the next maximum, it takes 3.14 years. That's what that's saying. Okay, so you've been taught how to do all this stuff, how to graph, and how to shift it, and how to shrink it, and how to stretch it, okay? Now we're saying, okay, what does all that mean? How can we use that? And that's what this is for. I no longer have to teach you what the sine of something is. I don't have to show you what the graph of it looks like. You guys have that. Now you have to apply it. All right. Let's do. Are you good, or you want to see another one?
We're good.
You good? All right. Here's your assignment.
Bailey.
Page 420. 420. Yep.
She's not back.
Hmm?
She's not back.
3 to 39 odds.